Hello. Welcome everyone. As usual, quick test. If everyone can let me know whether they can see me, hear me, all that sort of stuff. Make sure it's okay. Welcome to my stream. My name is Bruce Rain from Brankus Creations. If you have never watched one of my streams before, please jump on and say hello. In this video, we're going to be recapping yet another Macintosh SE 30. The reason why I recap so many of them is because, well, number one, they fail. All of them fail. And because they're a very popular Mac. People really love the high power of the, sort of the SE30 in the little compact Mac case. So I just noticed there briefly that my my webcam was doing some, what do you call that thing, auto-focusing, and I want to switch that off. So bear with me one moment here, where I go here to advanced, and I go focus auto off. There we go. It's always much better, because otherwise it's always zooming in and out, zooming in and out. So, so autofocus is now off, and now I can't see the chat. So, hello to all. Who have we got here? We've got, I can see, hello to Dana, hello to Steve, hello Krishna Draws, hello Charlie, hello Jay, hello Trina, hello Jeff. Did I miss anyone in that lot? I think I got everyone, but we are currently streaming with 8 concurrent viewers. So, audio and video good, scope cam quality to be determined. Yeah, I know that's always an issue. Nice shirt, thank you very much. This is one of the few shirts that I have that's not, all tatty. So I'm wearing this one today for live streaming. Hello to Malto Nito, hello, and Captain 318. So this is a Macintosh SE 30 that was sent to me by a customer. Hello to David. And it has horizontal lines, the striped zebra horizontal lines, which is one of the symptoms of what's often called CMAC on the SE 30. And as I've mentioned in my streams before, CMAC is a term given to essentially an SE30 that's not working. And I've often mentioned that when your computer has CMAC, it is not indicative of a specific problem. It's like an engine light going off in your car. There is a problem, but it's not necessarily telling you what it is. However, given the fact that we know that the SE30s suffer from leaky electrolytic capacitors, 9 times out of 10, fixing these, replacing these capacitors, I shouldn't say 9, it's nowhere near 9, it's more like 7, maybe 6.5 times out of 10, replacing the capacitors will fix the problem. The other problems that they encounter are that when the capacitors leak, they leak all over the place, and they cause problems with, we've got down here, we've got sound chips, and we've got display chips all in a row underneath here, and it's very common for sort of these to end up with display issues and stuff like that. And then of course down here you've got the ROM sim slot, and there are often problems related to that as well. So, but of course here is why everyone loves the SE30. 8 slots. You can put 128 megabytes of RAM in this old sucker. So, yeah. What is on your shirt? It is a scene from Star Trek. No, just joking. Star Wars. That's Jay's joke. Sorry. As usual, when I'm recapping, I have a cheat sheet. You'll find links to this in the description, which lets you know the capacitance and voltage of the capacitors, and where they're located, and their polarity and stuff like that. That's a new one. I don't watch Stargate. The fact that he knows what Stargate is an indication that I bet he does watch Stargate. One of the things I will be doing in this stream that I have never done before, how exciting is that, is when I come to remove these axial capacitors, which of course have holes that go through the board as opposed to the surface mount components, I will be using this. This is my new toy, which is a solder sucker vacuum pump thingy. For those who've never seen one or never used one before, basically they are essentially, this part is a soldering iron, except it's hollow. It has a little tube running, a little hollow running right through the middle of it, and the tip, which you're not going to be able to see because it's out of focus, has a hole in it. And so this basically just gets hot like a soldering iron. I have temperature controls as I would with a normal soldering station, and then that tube runs through here, goes into this little glass cylinder. Now, just in case you're wondering why my glass cylinder is so dirty, it's because on the day that I got this, I managed to drop it and smash it. So this glass cylinder is actually held together with JB weld. It works, but it just doesn't look too crash hot. I've actually got a new one on the way, but it's not here yet. So basically, there's an air pump here, which when I press the trigger, this sucks. There's a pump inside the base unit, and that sucks air through this tube, which then sucks air through this little glass area here, which then in turn sucks through the front there. So the air travels right the way along there, and then at this point here, right there, is a little filter that stops the solder going anywhere. So this gets the solder molten, then the vacuum sucks it in, then it goes into this little chamber, and then it stops at the filter and hardens. And so then you just intermittently take this little chamber out, you empty out all the solder, and then that's that. So if you're doing a lot of through-hole soldering rework or replacement, it's a handy thing to have. I have actually removed a couple of these RAM what do you call these? RAM slot thingies. I removed a couple of these using it, and it's a job that would have been an absolute nightmare using solder wick or a manual solder sucker. Using the sort of motorized vacuum pump, it just made a job like this an absolute piece of cake. So I'm pretty excited about that for future repairs. And as I say, I will be doing it on this here. But let's see how well it works. Yes, more fancy than your last sucker indeed. I still have this one here, and there are still advantages to using this. I mean, these really dish out a huge amount of sort of suction when they work. What's happened? I think it's full of something. It's getting blocked. It's not locking. Anyhow, well, that's a good time for this to break because I got this now. This can be fixed, I'm sure. It doesn't sound good, does it? Well, there was a load of something in there. That's better. So yeah, it was just full of solder. So these, as I say, still are quite handy, quite convenient. It's very easy to sort of grab this if you haven't fired up the other one. If you haven't switched it on and you can't be bothered waiting for it to heat up, you can just use this to remove a single one. And obviously wick as well also has a very important place. So I have been jabbering on here. How's everyone doing in the world of COVID at the moment? I hope everyone's staying safe, which seems to be the catchphrase at the moment. We're all in this together, and stay safe seems to be the catchphrase. Excuse me while I sip my tea. Because it is still morning time here. All right, I'm wearing gloves today. Don't normally do that, but I thought I'd be safe. So there we go. Right, so jumping across now to the microscope view, and we're going to just have a look at the areas that we usually know have problems. So let's get a little bit of focus going on here. There we have. So these are the three capacitors that are sitting next to the main sort of power plug. And as you can see, there's quite a bit of dust around it, and you can actually see that there's a bit of green corrosion around here as well. Sit around here. Now, it would appear that my the focus of my camera and my eyes are completely out. So just twiddle these little things, and then we're good. I don't like the look of this guy here. I don't know if you can see, but that is black around there. which would indicate some sort of short or something like that. There's a bit of burning there, so that's not ideal. Let's have a look at here. We've got this one here, and oh, look at that. Look at that. That's almost completely and totally rusted through. I don't think I'll have any trouble getting that one off. I probably won't have any trouble ripping a pad off that either if I try hard enough. Yeah, look at that. Rusty. Okay. Oh, I should also mention, just in the little picture-in-picture here, this one here is one of the later models of SE30. The earlier ones had a socketed CPU. This one is actually soldered on. So, just there we go. Just for a little bit of education. Oh, and the other difference is that on the earlier ones, I'm just going to go back to this image here. On the earlier ones, this capacitor here, which is located here. On the earlier ones, that capacitor is located underneath the RAM slot, around here somewhere, or around down here, something like that. So just, there are some differences between them. Essentially, they have all the same problems, but there are some minor differences in the board. So that hair stuff looks nasty. Yeah, I mean, look, it is dust. I know when you look at under a microscope, it looks like it's sort of pubes or something, but it is just hair. I mean, just dust. Now, that's an interesting one. We've actually had a capacitor fall off entirely. There used to be one here once upon a time, and that there looks like it's a little bit of component adhesive. I'm gonna have to lift that off. This did actually happen to me. Oh, look at that. Ho, 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 ho. We got some trace repair coming, folks. Oh, looking forward to cleaning that up. I mean, I can actually see, if we zoom in here, I can actually see here the channel that the copper should be in. There should be copper right there. There's actually, that channel is exposed, so we can clearly see that there is trace damage there. So, strap yourselves in, folks. This is going to be a big one. Just right. So that's great. That's really good. It's always great to see that. This is going to have a lot of fun in the ultrasonic cleaner as well, isn't it? And of course, we've got this little cap here, and then underneath here, these are these components that are part of the display. And in particular, the one that often gets affected is this one here, UE8. And it's not uncommon for that one to be a bit of a problem. Having said that, it's never been specifically UE8 for me. I mean, I just find it's any one of these ones that looks scungy. I actually have new replacements for all of these components. Every single one of these ones, excuse me, in a line. So if I do have any problems with those, I'm able to just swap them out with new ones. But what I can tell from looking at this straight off the bat is that this is not just a recap. This is a recap and repair. So, you know. Hey! Excuse me. Okay, so, well, first thing you have to do is get these old caps off because they're not doing any good here the way they are. Let me just jump across onto here. 14 concurrent viewers. Hello to any extra people that have jumped on since I welcomed everyone before. Please feel free to hop into the chat and say hello. I promise if I look up at the right time, I will say hello back. Right, so hot air station. It's where I usually start. Actually, where I usually start is my little heat. What do you call them? Heat shields, which we have. I have mentioned many times before, but my heat shields, I use little blades, you know, from like little, I call those little box cutter blades where you can snap them off the different lengths, and I use these because they're metal. They help absorb the heat. They stop plastic from melting. And on these old Macs, where I'd really rather not expose a lot of these components to heat, I like to sort of put a few heat shields in place. Wow. Just look at this. Look at this. Oh man, this is going to be fun. Yeah, I mean, I sort of feel almost inclined to take that component off, and you know, these ones, and then yeah, just clean all around here. But anyhow, we'll see what we can do. I should also mention I have replacements for. No, I don't. No, no. Yes, yes, I think I do. I have replacements for the sound chips, and I also have replacements for these VRAM chips. So I'm fairly well stocked up for replacing these things if I find any failed components. Okay, Micro Mage Repair. I don't think I have said hello to you, so I will say hello. And Retro Redrum, hello, how are you? Welcome, well, thank you for joining and welcome. And heat shield technique is really helpful. I'm glad to hear that, Charlie. It's good. It's good to try and share stuff with this as much as possible. Okay, so I'm going to start putting these heat shields down. I've got my little side angle view here, just like that, and it's not that good. I'll put that there. Put that there. So this is my 720p camera again. It's all flickery and horrible. I have got something on the way that I've ordered, which I'm expecting soon. Who knows how long it'll take with the whole COVID thing, but where I will be able to put a much better camera for this side view. So that's something to look forward to. All right, so little heat shield. There's a decent sized one here. So these here, which you can't see, these little two chips here, which are, yeah, there we go, that's slightly better. These two chips here are the sound chips. So it's very, very common whenever you have component failure or capacitor failure on this, that you lose sound on these things. It's one of the first things that happen. But of course, given the fact that this one has had a capacitor completely and totally fall off, anything is possible. Just putting these in place. I'm not too concerned about shielding this guy here. This is the big axial capacitor because I'm going to be replacing him anyway. So let's get some springs here, my little springs to hold these things up. Try and hold these things up. Get some more springs. There we go. I think I'll make a right mess of this now, aren't I? Make it look like I've never done this before. Having said that, it has been a while since I've done any SE30 recapping. Alright, that'll do. That'll do. Okay, so jump across to microscope. And this is really difficult. Hang on. I'm just going to move the microscope a bit so that I can get this onto the desk a little bit more. There we go. That's good. Right, so what we already know about these ones is they are corroded really badly. So they are probably just going to pop straight off, or they'll come off fairly easily, or they'll take pads with them, or, you know, anything is possible. I don't expect these ones to pop. So for anyone who's getting all worked up about that, oh, God, wrong setting. That's better. So yeah, if anyone's sort of getting excited and hoping for a pop, oh, it did pop. See, just shows what I know. It was more of a sort of a quiet fart than anything. Actually, it wasn't really a pop. Yeah, oh, geez, that one definitely popped. There we go. Threw those off, and oh, there is a smell in here. There is a smell. And anyone who has never recapped a computer of this vintage, I can tell you that the smell is the smell of the electrolyte burning, and it's disgusting. Thinking of buying a Macintosh portable pretty soon. Other than battery and cap issues, as well as the regular Mac issues like HD and floppy issues, what should I look out for? Everything. They are... Unfortunately, I'm zoomed out as far as I can go, Trina. Sorry about that. This is maximum out. I can zoom in, but I can't zoom out any further than that. Sorry about that. Yeah, so Macintosh portables are an interesting one. So I've just finished recapping one, and I'm actually working on a video at the moment, which will be coming out fairly soon. I've done the teardown. I've done the recapping. I just need to sort of film a little bit of an intro and an outro. Um, the the portable kind of has lots of problems, and there are two different types of portable as well. There's the backlit and the non-backlit. And I've only ever worked on backlit ones. I've never worked on the non-backlit ones. But it's really common for them to have trace damage like this, and it's common for them to have display issues. You can, of course, stick a SCSI to ST in it, but you'll need a special adapter because they're a slightly different plug. But you know, I mean, look, I like them. I would love to own one. I've only ever used other people's, but yeah, they are a pretty problematic Mac. And of course, getting RAM for them. You know, I mean, the one I've got's got like 5 megs in it, but the RAM adapter thing for it, it's not normal RAM. It's a little thing, a card that goes into a slot. So, you know, I mean, if you just get a bog standard one with, I think, what, 1 megabyte they came with, something like that, you know, you're not going to be able to do that much with it. But look, they're great Macs. But if you are planning on recapping them, it's very, very difficult to recap them without melting plastic, because there are capacitors literally like about 1.5 millimeters away from plastic. So there's not even room to fit a soldering iron in there in between the two. So just forewarning. But you'll see all that in the video when it comes out. So, hello, Matt. Welcome to the stream. And a portable is bad news. Just get a PowerBook 100. I kind of agree with Steve. I mean, I would love to own a portable just because they're a piece of historic Apple rubbish. And it's the rubbish that becomes worth something, you know, they're a lemon. But yeah, I do tend to agree that they're not really that good. But you know, very collectible. Yeah, I would like one, but you know, I think that you probably find yourself. Don't be surprised if you can't get it working. This one is the non-backlit. Yeah, okay. So they're a little, well, for starters, they're a real pain because you can't see the screen very well because they're not backlit. But you know, if you try and use them sort of even in low light, they're virtually impossible to use. They also have this little thing called a hybrid board, a little floating in the bottom left-hand corner of the board. And it's my understanding there are problems associated with that. But as I say, as I've never worked on one, I can't say for certain. The Mac TV portable and G3 AIO, interesting. Oh, I agree with you 100%, Charlie. I think that the lemons are great things to own. I mean, when you have these Macs that perhaps didn't sell very well because of all the problems, you know, they do become very collectible. I would love to have all those. Unfortunately, the AIO, or the Molar Macs as they are often referred to, they were never released here in Australia, so there are hardly any out here. And of course, if you wanted to try and bring one in from overseas, I mean, they've got that kind of brittle glass plastic issue. So, I mean, the chances of actually getting one out here in one piece is sort of virtually impossible. I digress. Right, so time for a few more heat shields. And, oops, this one. Yeah, Steve. When it comes to recapping the portable, I can't. I could lie to you and tell you it's easy, if you like, but it is not. It's not a fun job to recap. And it has 3 different types of cap that you need to replace. It has surface mount electrolytics, like the ones I'm replacing here now, and it has through-hole radial capacitors, and they are extremely prone to leakage in the portable. And it has axial capacitors, which are the ones where the leads come out either side. So 3 types of caps. The axials you could probably get away without replacing, but you know, if you're going to be doing it, you may as well replace them. And the radials, the through-hole radials, they have to be replaced. They are, you know, sort of, they leak terribly. All right, let's see if I can get this one out without melting anything. I'm having trouble getting at the right angle here, so I might just change views, side angle. while I point this straight down. If you're wondering what that weird noise was in the background, that's my chickens. They're objecting to something. Can't tell you what. They're objecting to something. Probably a raven or something in the yard, freaking it out. And they make a huge racket just as part of their defense. Okay. You have chickens. I do indeed have chickens. I have 7 chickens. And yeah, I have to say that I love fresh eggs. It all started one day when I went on a walk with my wife just around the local neighbourhood, and we were in a park and just walking around the park, getting some exercise, doing some laps, and we found that was a big one. We found 3 chickens just wandering around the park, little tiny ones, little baby ones. And, you know, okay, well, they can't stay here. I mean, they'll get hammered by the first dog or cat that comes by. And then we brought them home, and I went out and bought a little coop for them and everything like that. And within a few weeks, we found out the 2 of them were actually roosters, and only one was a hen. And we ended up taking the roosters to a animal sanctuary thing, because you're not legally allowed to own roosters in this residential area. It is actually against the law. So we took them to this little wildlife sanctuary place, and while we're there, I said, look, you know, we've got this one chicken, one hen now. We'd like to get some friends for it. And he said, oh, there's a poultry farm just down the road, and they sell young chickens, what they refer to as pullets. And so we popped in there on the way home, and we bought 2 more, and then the rest is history. We now have 7. So, and we have a very good supply of fresh eggs. Okay, here's another capacitor. This one actually looks in pretty good condition. This one hasn't leaked that much at all. We have a little section of our backyard sort of fenced off for the chickens, or chooks as we say here in Australia. And they are, it's a very large area, and they've got lots of sort of bushes and stuff to hide under, and they can't get out of it, and yeah, it's great. And then we just sort of lock them up at night. Matt says he has 10 chickens. That's awesome. Deviled eggs, yes, indeed. Makes sense. We want the roosters waking up the whole neighbourhood. Yeah, I mean, roosters they make noise at daylight. I mean, it's just their nature. They can't help it. That's what they do. So, you know, that's one of the reasons why they've basically said, you know, it's not like you can send them off to obedience training or something to not wake up the neighbourhood. So, yeah, that's that. Right now. Your house is fried. Yes. Yeah. Did you complete your defensive driving course? Nami. Oh, Nami's here. Hello, Nami. I got some more little poopy comments on a couple of my videos from you the other day. Something about, and there was some stuff about a newsreader or something. And yeah, it's there's either you're waking up in the night and having weird sort of moments of kind of comments where you just sort of like maybe sleep commenting, or you have a someone has hacked your account. There is a third option, and that was you could just be obsessed with poopy diapers. So okay, so what I just did then, I really should have explained what I did then. I have a this is the plastic connector for plugging in the power supply and everything like that. Now, so So yeah, so I'm just reading the chat here. Yeah, yeah. No, I mean, I recommend you try and figure out who is well. If it is you posting, then I'd recommend you cease and desist from that. If it is someone else hacked into your account, you need to try and sort something out there, because that was only a few days ago that those comments came in. So this is a plastic connector here, and so I don't want to melt this, and there are these capacitors right next to it. Now I will just do my normal heat shield going down there, but I also put on this Captain tape, this heat resistant tape on it as well, just to provide a little bit of extra protection in case there's any you know, extra, you know, sort of any airflow that gets underneath. So all right, heat shrink, heat. I keep like to say heat, a combination between heat shield and heat shrink. Okay, microscope big. Okay, right, these are going to come off. There's going to be some interesting stuff to discover once we get all these off. I'm sure of it. These are the last three, by the way. I've taken all the other capacitors off while I've been chatting away. If at any stage anyone has any questions about the way I do things, or why I do things in a particular way, or what's going on, or anything like that, you can ask me totally unrelated questions if you want. Okay. And there we go. Ooh, that one popped as I took it off. I went pfft. Pfft. Right, so now we have yes, I know. I mean, look, at the end of the day, there are a few things about this board where you'd like to go back to the designers of this and say, hey, can you redesign this to not put the leaky capacitors next to things that they might damage? But yeah, they weren't really thinking of that at the time. Let's face it. This is an Nami. This is a Macintosh SE 30, which is a bit of a giveaway in the name of this stream. Okay. Righty. So, we now have, I'm just going to jump across to this view. We now have all of the surface mount electrolytic capacitors removed. We have two, I'm not mirrored, so it's really hard for me to work out which way I'm pointing. We have two axial capacitors that I need to remove, and normally what I would do when I'm removing these is I would cut the leads, take the capacitor off, and then use a little bit of heat to pull out the lead. But what I'm going to do this time, I'm going to grab my solder suckery thingy, new thingy, like this, and remove the leads. Now, I don't have a good camera set up for doing this, so I do apologize, but I will try and get some light over here so we can see. And so we've basically got one lead here. Oh, geez, I need my glasses. Sorry. I mean, I've got my glasses on, I realise that, but I need more glasses. Okay, so we've got one right here. It's a terrible view, I know. But basically what we do with this is we just get, I'm just going to wait for this to heat up. This takes forever. I mean, I'm so spoiled with my soldering irons. See, this is a cheapie. You can buy really expensive ones of these, but this is not that. This is a cheapie. And the whole idea with this was just to see what it was like. And I will be doing a video later on where I go into a bit more detail. But basically with this, we just put the hole in the little tip over top of the where the pin sticks out. We melt that solder, and then we suck. And it just sucks all the solder out. Let me do the same here for this one. If you end up in a situation where you're having trouble getting the solder out, like this one here, the best thing to do is actually add more solder. It always seems counterintuitive to do, but it works. You add more solder, and to wherever it is here, add some more solder to it, and add a lot. Go a bit crazy. Put heaps on, and then we get this little guy, and we melt that solder and suck. and it's still not there. Yeah, that's all blocked up. Successful test. So we might be going back to the old-fashioned way of doing it. However, if I was wanting to take one of these out, it'd be excellent. Let's try it on the other one here. So, yeah. We'll have a look at this on the microscope when I'm finished, and you'll be able to see what it's done. Right, so that's those done. And let's have a look under the microscope and just see what sort of job it did. Can't see with these on. I mean, you can see up close, but glasses to 500%, yes. Can I use the curling iron? For sure. Yep. I mean, for doing your hair, absolutely. Don't add flux, it gums up the sucker, learn the hard way. Okay, well, I will remember that, because I haven't done that yet. I haven't added any flux, but yeah, that does make perfect sense. Okay, so let's have a look at these holes. Right. Well, as you can see, I mean, that has actually done quite a good job. I mean, it was still a little bit stuck to the side, but with a bit of a pull that would have come out. This one here, that's the same. That's pretty much out, so I can get rid of that. Yep, so that's not looking too bad. So that one's okay. I mean, I don't really see any issues here. I should be able to just grab this one and out she comes. Hey! So there's one little axial capacitor. Let's zoom down onto this. So as you can see, this one didn't suck a lot of that solder out of there. And that one got most of it out. So that side, yeah, that one's come out quite easily. So now we just get to this one here. But for this one, because now I've got one side out, it's really easy to get the other side out. I am going to add some flux because that solder looks so crunchy. Which flux is this? And which flux is this? It was really stupid of me to put them in the same syringes, seeing as they're different. That's the good stuff. I can tell because it's clear-ish. So let's just apply some heat to that. Get some nice fresh solder on there. See as when I do that, can you see all of these crunchy bits coming out the side here? Just there. See all that? That new solder is displacing all of that old crunchy solder, and that's why putting new solder on is so important. I say this all the time, you know, add new solder to it. It's like, you know, that's counterintuitive. You're adding new solder when you want to take solder away. But as you can see, that when I added that new solder, it pushed all that old crunchy solder to the side, and that sort of then makes the joint a lot easier to fix up. So, oh wow, okay, there's been some chat here. It's a nice clean hole. That cheapo thing actually does a very nice job. It does, yeah. I mean, I'll demonstrate a little bit more in the stream. It does some really good stuff. Yeah. So just bear with me a second. I'm just going to do that. Which one did you end up getting? Oh, hello, Oz RetroComp. Thanks for joining. The one I ended up getting was the Rhino. It's branded as Rhino, but at the end of the day, it's just one particular model. I've got it. Yeah, got it here. Sorry, I took a photo of the model number, and I just opened up my phone and I just instinctively went to Facebook. Okay. Let's scroll up until we find the photo, shall we? There it is. Okay, so this is not rhino, it's hippo. So it's hippo. So just think of a different African animal. So this is a ZD, ZD, depending on which country you come from, ZD dash, well, it's an 8915, but you'll find ZD 915 around. I think the 8 merely means that it's a 240 volt version. You know, it's our electricity version. I think the 110 volt is the ZD 915. So there are lots of different brandings of the same solar station. It has temperature control. It's very easy interface to use. Yeah, and look, apart from the fact that I feel like this mechanism here is a little bit clunky and cheap feeling. Once you get used to it, it's okay. So basically what happens is this little end piece holds it in. So when you press down here, or up, this comes out and then you can pull this chamber out. And I find the process of getting that chamber in and out a little bit kind of difficult, but that may be the same with the more expensive ones. I don't know. I've never used them. So, but anyhow, on the whole, pretty darn happy with it. ZD985. Yeah, there you go. See, you knew it before I did. Finally turned on. No, he didn't. Do you want me to? I'm going to do it. I'm going to do my do not disturb. Do not disturb. Oh, on. There we go. Sorry, there's chat. For those of you who are not aware of Mac Yak, and most of you probably are on here, you're probably sort of watchers of the Mac Yak show. But those of you who are not aware of Mac Yak, there is a group of people who get together and talk about Macs on a weekly basis. Jump onto the website if you like, or onto the YouTube channel. You can have a look. And the fellow Mac-Yackers, we have a shared sort of Apple iMessage chat, and they're chatting a lot at the moment. So anyhow, okay. Oh no, would never badmouth the Mac-Yackers. Come on, bad mouthing them is bad mouthing me, because we are a whole. So there you go. Nearly finished my tea. It's a little bit cold now. Okay, let's get that out of the way and start focusing on stuff. Oh, yeah, okay. So, sorry, I've just been missing bits of the chat here. I've been eyeing one of those off for a while, so looking forward to hearing your thoughts. Yeah, I mean, look, so far my thoughts of this solar suckery thingy are really good. For the price, I mean, it's expensive, more expensive here in Australia than it is in the US, but for the price compared to some of the more expensive ones, you know, if I was to say compare it to that like Hacko equivalent, we're talking about like about $500 cheaper here in Australia. And for that difference, I'm pretty pleased. You know, so anyhow. All right. So I was in the middle of removing a capacitor here, and so I'm going to jump across to there. And to there. There we go. So I'm just going to apply some heat. This is where I put the new solder on. I'll apply some heat here, melt that solder, and then pull that out. There we go. So now we just have to clean up these little holes here. There's one there. Just a little bit of flux on there. And I'll get a little bit of wick. Wickety wick. Wickety wick. Wickety whack. Solder wick, John Wick. And here we go. I mean, that's one of the advantages of using the solder sucker, is that the hole ends up getting clean. Except for this one that I had trouble with. This is I think the problem hole. In that I think on the other side, it's got a huge ground plane, so it sucks a lot of the heat away. So I'm just going to add some more solder. And then we are going to try and get all that solder out. Come on, man. Flip it over onto the other side. The other two are fine. Yeah, it's just that one thing. That stupid thing. Sorry, I just have to find it on the other side. There it is. Found it. And yes, as I mentioned before, it is attached to a great big ground plane. There it is there. So all of this, checkered copper that you see here, this is basically sucking all the heat of the soldering iron away. So that heat is not getting where I want it, and that's why it's not getting all the way through the hole, and I'm not getting the solder out. Do not vex me. You know what I could try? Well, what I am going to try. Add some solder there. Nice fresh solder. Looking fresh. So fresh and so clean. And then I'm going to go side angle. I'm going to grab this. Put on my super magnifying specs. I'm going to see if I can melt this and suck it all out. And it bloody worked. See? 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 Look at that. Let's jump across to the microscope big. Look. No. Is that it? Yeah. Yeah, look at that. Straight through. And straight out of focus. Right. Looking good. Okay. So, what have we got? What are we missing here? I'll leave you to do work now. Thank you. How does that solder sucker handle those ground plane holes? Well, that was the one that it did actually have trouble with when I was doing it originally. So it did actually have trouble. Well, quarters are worth $800. Dream one where they're still $8 and already recapped. I've actually got a Quadra 700 on its way to me now that needs repair, so it'll be an interesting live stream with that one because I don't know what I think it's in a really bad state inside, so we'll see. Called Goldman. Aha! Yeah, so for those who aren't aware of the reference to Goldman, it has to do with a particular person who likes to sell stuff at a fairly inflated rate on eBay and Facebook, Mac-related vintage stuff. There is a completely different price, sort of, what would you call it? Sort of like his idea of what things are worth is kind of just nowhere near what the market is. So, yeah. Stepping out for a snack. Okay, Jay. I will just try and kill some time until you get back. Okay, so this is really weird. This is almost as if there was never a capacitor on this. That's strange, because the component adhesive wasn't squished down like the others. I don't know. I'm just mildly confused. I'm just applying a very small amount of heat to get these off. I don't want to melt any plastic, but I can't be bothered putting a heat shield down. There we go. Looking good. Just these little bits of, these little bits of component adhesive. So I've mentioned this in one of my streams before. When they're building these boards, when they're making them, when they're doing surface mount components, what they do is a little robot thingy puts the component in place with some component adhesive, and that holds it in place before there's any solder. And then they just run solder on, they run it across the solder bath at kind of big bath of molten solder, and the solder just sticks to anything metal. And so, yeah, that's why they have the component adhesive on this. You won't see it on the modern ones because they don't work like that anymore. All right. One more little bit of component adhesive here. Off you come. I don't like leaving the adhesive on because then I can't get my new component flush on the board. Yeah, there should be a cap in that spot. There definitely should be a cap in that spot. 16 volt, 47 microfarad. So, yeah, even though sort of there's nothing there on this one, it definitely should have a cap there. So I don't know what's going on. So, all right. So next thing is cleaning, and as I have already said on this, we have some problems in this particular region. I'm going to take this component off as well, so I'll clean up around that one too. So I'm going to get me some flux. I think this is the cheap stuff. Yeah, this is the cheap white stuff that smells like fairy floss. And what do you guys call it? Cotton candy. What we call fairy floss. Okay. No. Okay, so, I'm saying okay a lot, aren't I? Let's take this guy off. And incidentally, this little one I'm taking off here, I think, is one of the chips for one of the serial ports. So, what? Okay, all right. Tell him he's dreaming. Who said that? Tell him he's dreaming. Oz Retrocom. Yep. It had to be an Australian saying that because that is definitely an Australian saying. It's a saying from a movie called The Castle, where one of the characters spends all of his day looking in the trading post, like the trading magazine, and and any time he finds something in there at a particular price, he sort of says to his father, he's got a pair of jousting sticks for sale. How much are they? And it's like $300. Tell him he's dreaming. So anyhow, yes, I mean the castle is good fun. There's lots of very Australian humour. I suspect that people in sort of America might find it a little bit like watching paint dry, but certainly for Australians, there's lots of very, very Australian humour in it, and it's good giggle. Okay, so I am just planting flux all over the place here. It's just a fluxathon, and then I'm going to add some new solder to all of these pads, and I'm going to very gently apply new solder and a bit of heat and a little bit of motion, just very, very gently moving around. I am not pushing down very hard because I know for sure that all of these pads will be very, very brittle, and I don't want to have to repair any. So but what I'm looking to do is, as you can see, when I first apply the solder, I get this bit where the solder doesn't stick. It's this little bit here where it's got this black crusty corrosion on it. But with a lot of with applying the heat, the flux and the solder and this motion, eventually I get rid of that little black section. Oh. My alarm's going off. I'm a bit stupid. There we go. All right. My watch is telling me to stand. Can I trick it into thinking I'm standing? I'm standing now. Right, so once I reach a point where I can see solder adhering to the whole pad rather than just to one half of it, I know that I've done the job. I'm going to add some more flux. Needing a lot of flux for this one here. It's all getting burned away. Okay, and then I'll grab my wick once again, and we're now going to take away one thing about the current lockdown. How's the Serenity? Oh yeah, the Serenity is nice. So, okay, all right. Let's get rid of all this. And as you can see, once we've finished with this, we get left with these rather nice looking shiny pads, all ready for the component to go back on. Clip. And when you're soldering anything, what you want is the two surfaces you're trying to solder together to be clean. It's one of the most important things, you know, when you're soldering. Okay, look at that. What a mess. All right. Oops. Oh, what's it saying? Oops. Okay. I tell you what, some of the routine gets a bit thrown out when you're sort of staying in the house all the time. I kind of forget what day it is a lot of the time. But we know what day it is today. Streaming day! Yay! Okay, so I'm going to hit these traces here with my trusty scalpel. Links in the description. Oh, okay, yeah, it still works. So before, no sound. Okay, yeah. Right. What have we got here? I have a question for Dana or Londo's hair. How are you going with your G5? Okay, so let's just jump across here. I have 22 viewers. Wonderful. I'm very happy with that. Hello to everyone. We were currently working on an SE30. I'm going to just get rid of some of this scungy old flux with a Q-tip and some isopropyl alcohol, also known as hand wash. And really what I want to do is I want to expose these traces, and I need to know where there's a break, where there's actually a break in the trace, and where it's just a matter of some black stuff on top. Now I can see already here where there's a break. Hey, SI arriving tomorrow. Nami has just said he's got an SI coming, and yes, they do have problems because they have really bad power supplies. I have one floating around here somewhere, actually, or at least pieces of one. So this is a Macintosh 2 SI power supply, parts of it, and I'm not sure how complete this is. I think it's a bit incomplete. I'm getting confused. I'm so confused. Ah, there it is, yeah. Okay, so they have this little... Okay, so the main problem with an SI power supply, first of all of these capacitors here like to leak. Yay, aren't we happy with that? Then the other issue we have with them... So, all these capacitors like to leak. The other issue you have is that there's a little daughter card thingy which slots in here, and that has surface mount electrolytic capacitors on it, and they leak. So it's a Macintosh SI that has capacitor leakage on the logic board. It has capacitor leakage on the power supply and on that little daughter card on the power supply. So when you buy a Macintosh 2 SI that has not been recapped, expect it to not work. So, oh yes, and of course I haven't even mentioned the battery problems. So, Right, so as I scrape away at these traces, I'm seeing some areas where I'm revealing copper, as you can see what I'm doing here as I scrapey. I am revealing some areas of nice clean copper. I'm also revealing some areas of blackness. Just got to keep going with this, I'm afraid. It's just, this has to be done. And then at the end of it, I'll then make a decision about what we're going to, just try and keep the existing trace. We'll just tin it with a bit of solder, make it look nice. And some of them we will have to actually repair. And this is obviously one we need to repair. That's completely gone. Gone. Right. Okay, now where's this? I asked. Oh, it's properly stuffed. Oh, that's no good. That's so okay. So even trying different RAM, because I know you bought new RAM for it or something. Even if you try completely different RAM, it's still stuffed. I mean, it's definitely not the RAM. I take it. Dana, I'm talking to you, by the way. Scale of 1 to BBC Micro. How bad is the 2SI PSU? Put it this way: if we put it on a scale of Macintosh, it's pretty much the worst power supply that you'll come across. So there you go. I mean, having said that, I love the 2SI. And when you do fix all these things, when you replace the caps and you recap them and you get it all working and everything, they're a great little Mac. I mean, they're just, I love the form factor. They're just awesome. I've actually got a couple of cases over there. I bought a few of them. So I have lots of spare parts. One of them, train wreck. You have never seen a board as bad as this one. But anyhow. Okay. Still going here. So I know how boring this is, and I do apologize. What I really want to do is I want to see copper, because I really don't want to have to repair all of these traces. That would suck. But it looks like I'll probably need to do some repair on this one. I don't like those big black pits. This one maybe, probably. Again, it's got these black pits along here. And this one definitely, because it's actually completely and totally rotten through. A few pits there. Joys. Right. All right. So, what causes the trace to go black? So, it's basically just corrosion. So copper, like most metals, copper oxidizes and rusts the same as like steel does. Steel, when it gets exposed to air. Now, what happens is that these have all got this coating on it, this solder mask coating. It's the green stuff. When the capacitor, the electrolyte leakage comes onto the board, it actually starts to corrode away that coating. And as that coating goes away, it leaves that copper exposed to the air and obviously to the electrolyte as well. And it then causes corrosion. So the blackening is essentially just that copper corroding underneath the trace. The solder mask. Okay. The liquid cooler leaked. CPU dies are covered in corrosion. Jay and I think it's fixable, but needs new, better O-rings and a solid cleaning. Yeah, that sucks. That is not a job I would want to take on. So, you did interesting stuff. Follow us away. How dare you? Oh, did I? Sorry. I didn't think I did do anything interesting. But anyhow. Right. I am just going to. Okay, so we are going to continue here, and we're going to now clean up these pads here. Still don't have a suitable reason why that capacitor was not there, because as I say, I mean, when a capacitor falls off, kind of looks like this, where you can see, you know, there's a groove left behind, whereas there's none on this. I mean, that capacitor really does look like it was never there. And maybe it wasn't. I mean, maybe this computer has never had a capacitor there and been problematic from day one. Who knows? Hello, Dan, watching from Washington State, US. Hello and welcome. I'm glad you enjoy it. I'm glad you enjoy the stream. I do enjoy sharing this stuff with others. Okay, so this is me continually losing focus and then getting back into it. So once again, what I'm doing here is I'm applying sort of new solder to these old pads, and I'm working around until I see the black gunk disappear and I get to a point where I can see solder is adhering to the whole pad. And as I've said before in my streams, one of the really important things here is to be super gentle. I'm not really scraping hard. It might seem like I am, but I'm very, very gently touching these pads because it really doesn't take much to destroy one of these pads. Rip it off, tear it, damage it, remove it, and I'm out of camera. Thank you. And then we get up here. Keep going with cleaning. And there we go. A little bit of black there, just a little black dot on the left of that one. It's not giving up easily. So we'll see how we go. Yes, thank you for mentioning that, Jay. For those not aware, I do have a website called recapamac.com.au, and on that website you will find recapping guides to a lot of Macs. Not all of them, but a lot of the ones that need new caps. So when I received SE30, all the connectors were disconnected from the board. Oh, DD Electrical. I am assuming this is your board. Is that correct? Yes, of course. Yes, that all makes sense. Trust me to have a weird board that doesn't have a capacitor in there. Yes, it all makes sense now. So just sort of for those, you know, sort of watching the stream, DD Electrical is David, who owns this. And so he's watching now, so I have to actually start doing a really good job. Right, let's continue here, and we'll start trying to get some of this solder off these pads and making them all look sparkling clean. Yes, and there's, as we can see, this is the little bit I was having trouble with before. I think there's a little pit inside this pad. It's not the end of the world because it's only small, but yeah, there we go. Scrape it off, end up with copper there. Much better, looks good. So all the chat's going fast now. Any tips of tracking down? An interesting thing about this SE30 is the ROM sim, the little ROM sim that slots in it. It's very different to any I've seen before. So, I mean, it says Apple Computer, and I assume it's legit, but it looks very different to any of the ones I've encountered in the past. Any tips for tracking down the cause of video distortion on an SE30 after recap? I've been testing a ton of traces. I haven't figured it out yet. I get those thin vertical lines. Thin vertical lines. Okay, I can tell you what the most probable cause for that is. Thin vertical lines are probably a failure in one of these two chips here. It can also be a problem with the trace on one of these. You know, so these chips here need to be cleaned really, really, really thoroughly, and look out for any broken traces. Get a multimeter and test the pin to wherever the trace goes, and check that there aren't any breaks in those. And then failing that, it could be one of these two chips here. So, right. So, so I'm assuming that your computer actually boots up, starts up, and everything like that, but you just have little thin lines running through it. That's what I'm assuming. So, I think that's the same problem I was trying to fix. So the problem I'm trying to fix is actually a broader kind of jail bar. This is one where it won't even boot. You won't even, you can't start it up or anything like that. And this is sort of more of a CMAC type issue. Whereas there is another issue which I've encountered in the past where the computer boots up, it all works, but you have little thin vertical lines distorting the screen. Yes, thank you. Okay, so incidentally, if anyone feels like if they're here for the first time and haven't subscribed before, and they're just feeling in the mood to subscribe to a new channel, please feel free to subscribe to this one. I am hovering, I think, at around about 970 or 960 or something like that. I'm aiming for that magic 1000, and I'm hoping to get there in the next few days, which would be nice. Sort of feel it's a real sense of achievement when you hit that, I feel. So feel free to subscribe and like and all that sort of stuff. All the fun things we do, I can do my YouTuber voice. Hey, what's up, guys? Thanks for joining. Don't forget to press that like button. Okay. Just continuing to clean the pads here. I know it's a little bit on the dull side, but it is necessary. We want to do a good job with these. We want to try and get it working again. I haven't got the microscope view. Sorry. Right. Now, what I'm going to do now is get a little bit of smash that bell, guys. Unless, of course, you hate my guts, you think I'm a waste of space, in which case, click the thumbs down. Just doing a little bit of clean up here. This Q-tip has cleaned its last. Yeah, it's so funny. I mean, I know this is a sign of the times, and this is just the way I feel, and I'm old and crusty. But when I watch a show and someone puts their job description as influencer or content creator, I cannot help but feel a little bit cynical. And I know that's wrong of me because I know people make money from it. So it is, strictly speaking, a profession. But I don't know. All right. Do every stream with that voice starting now. Hey, what's up, guys? Who knows? I might get more subscribers. So glad you could join me. Yeah, thanks. You know what we're doing here? We're scraping off some traces. It's a great day for it. I'll stop now. Okay, so there was a lot of blackening on that trace there, but once I scrape away that blackening, I see copper underneath, so I don't see a need to do a repair there. That'll just be a matter of getting a little bit of solder on the top of that to protect it. Same with that one there, just working my way through. So we've definitely got broken traces here, but it's not as bad as it could be. So, He sounds unnaturally different. Yeah. We could do it like sort of late night radio. Hey there, everyone. Thanks for joining. Okay. More scraping. I mean, I realise this is just is really not particularly interesting, but this is a necessary requirement. And obviously we do this while we don't have the caps in place. I don't like the look of the pitting on this one, so I'm probably going to end up doing a little trace repair on that too. Anyone who has not watched one of my trace repairs before, you'll get to see how exciting it is. Right, so that I feel like I have addressed all of the issues around there. I am probably going to put the components on before I do these trace repairs. I do need to get some solder on these though. So what I generally do when I want to get a coating of solder, oh man, look at all the hair on this. Yes, I do thank everyone for watching. This must be a good time to stream because I've got a reasonable number of viewers. So thanks to everyone for whether you be in Australia and be like the middle of the day here, sort of lunchtime-ish, or in another part of the world where it is probably a completely different time of the day or night. Okay, so basically what I've done is I've got some solder onto the tip of the iron, and then I get my clean wick and I make sure I get that solder all over the wick, which then as I scrape transfers onto these traces. So as we can see, now what I'm actually doing at the moment, I have to stress that when I'm doing this, I might make it actually look a little bit easier than it is. When you're doing that sort of stuff where you're actually trying to coat traces with some solder wick like that, if you're not careful, it's very easy for the wick to catch. You know, so in other words, at a certain spot on the wick, the solder might cool down, and then it actually solders onto the trace, and then as you slide along, you just lift up that trace and you make a mess. So just be warned that what I'm doing there, although I might make it look like, oh, wish, you know, you've got to have confidence in the temperature of your soldering iron. I'm doing this with a bevel tip so that it's got a flat side here, which helps me get that heat where I want it. And so as I move that wick around, I know that I'm fairly confident that it's not going to stick anywhere. So, but I just want to mention that because if you're watching this and you think, oh, I'm just going to do the same thing, you know, do it really slowly and carefully to start off with. And the moment you feel a grab on that wick, you know, stop pulling on it because otherwise you'll tear off a pad or a trace or something like that. So just mentioning that for anyone who might be planning to do a similar thing, playing along at home, as they say. Okay. Just still cleaning, getting all this stuff off. Okay, so a few things that I want to mention that are potential problems. And that is, well, they are that we've got some exposed traces around here and around here. And as I've mentioned before, when I put on a new component, I'm putting on tantalum capacitors replacing the electrolytic. And the pins on the tantalum are wider than the ones on the electrolytic. So the pins actually take up more space on this pad. So you might actually end up with a situation where that pin overlaps this trace here. Now, if you've cut through that and you've exposed a little bit of that trace, you can end up creating an accidental short. And same around these sort of areas here. And that's where I really do like to coat with a little bit of UV solder mask, which puts an insulated coating over top of that. I just realized that I've got this exposed copper here. And when you've got exposed copper, you've got to do one of two things with it. You've either got to tin it, get a little bit of solder on it, or you've got to paint UV solder mask on it. So I'm going to do this. I'll probably end up doing both, but I just want to add some solder first of all, just to shore up these connections, and then I'll put some UV solder mask on it to just to seal it up. Right. So, how's everyone going? Good? I hope. Yeah. I will be recapping a 610 fairly soon. This is him over here. Now, this is actually a Centrus 610 that I'll be recapping, but I have this Centrus 610 has a 68 LC 040 chip on it, which means it has no FPU built in, but I actually have one with an FPU built in. So when I recap it, I'm also going to swap over the CPU so that we can ramp it up from a Centrus 610 to a Quadra 610. I think that's the main difference between the two. Right, so I just need to keep cleaning this, because if I'm going to put UV solder mask on it, it's got to be free of old, what do you call the stuff? Of old flux, because I need to have a nice clean surface for the UV solder mask to stick to. May your 610 not need a wire running from the back to the front. Yeah, I hope it doesn't. I do hope it doesn't. Okay, cleaning. So, the big problem I always have with UV solder mask is it takes time to dry, and that's really difficult when it comes to doing a live stream. I want to keep going with the stream. I want to keep doing it, but at the same time, I do want to make sure I do this properly, and I want to get the UV solder mask on there. So what I will do is I'll paint this on. I will continue with the other parts, and with a little bit of luck, it might dry in time. It's reasonably sunny outside. So this is UV solder mask. There are links in the description for buying this stuff. And I'm basically just going to paint this on with a fine toothbrush. And I'm just going to coat all of these areas that might present a problem when we put the component in place. My watch just went off. Okay. It's a totally unrelated chatter going on with the Mac Yackers, so I really don't need to read that. I'm just always worried about, while I'm streaming, if one of them sends me a message and says, "Hey man, your sound's going like crap," or something like that. So I sort of look at it quite regularly when I see it buzz. Okay, continuing. I won't be UV solder masking up here because I have got to do trace repairs on those. But now this one here. What do I do? I think I'll probably just sit this component down a little bit so that it doesn't get in the way of that. I don't think I need to repair this part, so I can coat that. Do. Okay, a little bit more there. Now, needless to say, when I'm looking through this microscope, I can't check the chat, so if anyone's typed anything and they're waiting for me to respond, I apologise. I will read when I take my eyes off the microscope. Okay. All right. Yeah, I mean the 610, the 6100, the 660 OV. I do like all of the computers that came in that large pizza box form factor, the family size pizza. So here is my UV globe, and sometimes when I switch it on, it comes on. Other times it doesn't come on, and I have to go over here. Bear with me a second. And I have to go over here and twiddle this little plug like that, just like that. And then we have glorious UV light. It's not particularly powerful UV light, but you know. So I need to somehow or other be drying that at the same time as working, which I've tried before and is a challenge, I'll admit. Let's now continue with this one here. We'll just continue cleaning. I'm just going to get rid of this bit of adhesive. There we go. Oh, hello, Madeline. Welcome to the stream. I mentioned earlier on in the stream that I had been working on a Macintosh portable, and that belongs to Madeline. I probably should mention, I have finished recapping it, and it's working quite well. Using system 701, I think it seems to be a system that is a really good one for that. Generally with the old 68000 chips, anything newer than about system 7.01, it'll run, but it just doesn't run too well. So system 6 or system 7, not 7.5 or 7.6 or anything like that. So yeah, the old portable seems to be running quite well under system 701. So and your 2VX, which I also have here, that's running beautifully now as well, but I'm probably going to need to recap the CD-ROM drive, because that's one of the old caddy loading, and they suffer from leaky caps as well. Okay, cleaning that up. This UV light's really getting in my way. I'm heading out now. Good luck with the rest of the recap. Thank you. See you, Charlie. Thanks for joining. I promise not to do anything too exciting with you not being here. Okay. I get some of this. Once again, I just don't like seeing any little black on these pads. I want to see either copper or solder. So there we go. Right. That one's a nice clean one, ready for a new cap. Someone's burning. It's always scary whenever you're in a place like this and you smell burning. There was one day where I was sitting in here working, and I just got this incredibly strong smell of like plastic burning. I'm like, what is that? And I'm looking around, getting ready to grab the fire extinguisher, like, what's happening? And then I just realised that the next street over, someone had done a huge burnout, and the smell of the burning rubber from their burnout was just starting to waft across the backyard. So that was that. Yeah, lockdown blues. This is right. I mean, it's like, is picking up a Macintosh portable essential travel? I don't know. You have to. I've got a few little black dots on this trace, so I want to clean it up. And this one's going to need some UV solder mask as well. Tissue. Alright. Right, there we go. It's clean now. And time for more UV solder mask. I have a little trick when it's sunny. Oh, it's getting overcast now. When it's sunny, I have a little trick for drying UV solder mask really fast. I basically just get a magnifying glass, and I go out and I sort of magnify the sun down to a dot around about the size of a an Australian 20-cent piece, which is a little bit bigger than a US quarter. And and using the magnifying glass to sort of magnify the sun, it really dries off this UV solder mask quickly. There are special UV lights that do this quicker. This doesn't do it particularly quickly, but I don't have them. I have this, and so that's that. Right, but of course we're finding all sorts of fun and games with this board everywhere we look. Now we've got this little guy on his lonesome. This one looks like a nice easy one. So once again, solder on. Sorry, flux on. So the traces can oxidize even under the solder mask. They can if there's something that's caused the solder mask to weaken, you know, and let air in, and that's usually by you know, sort of moisture can do it. Flux, what do you call it? Electrolyte can do it from leaky capacitors. So yeah, I mean, if you were storing these in ideal environments, the solder mask would be fine. It wouldn't corrode underneath it. But you know, when you have things like water, you know, moisture or electrolyte getting in there, different story. Okay, cleaning this one up. This one's a nice one. I like this one. It'd be nice if they were all like this, but then again, if they're all like this, this thing would probably just work. So, here's another one in a little village of plastic. I'm doing him that way around because he's in a little village of plastic. We've got, this is the ROM slot. This is the PDS slot. This is the battery holder. So, plastic galore. And we add some solder. I know there's a lot of repetition when I'm doing this. I basically just go through the same process over and over again. And in this stage, unfortunately, this is the part where, you know, there's no real diagnostic going on. So when I actually have finished this and got new caps on it, if I fire it up and it's still not working, then I've got some diagnostics work to do at this stage. But, you know, the thing is, there is quite literally no point in doing diagnostic work before replacing the capacitors. And this is one of the things I say to people, you know, when they post on Facebook or something like that, or on a group, and they say, oh, I've got this Mac, it hasn't been recapped, and it's doing this. You know, I know it hasn't been recapped yet, but, you know, can anyone tell me what it might be? And it's like, well, it could be lots of things, but there is really no point in doing any form of diagnosis when you know that there is like a failure point on there. You know, you have to do those caps. I mean, they're leaking, they're causing corrosion, all that sort of stuff. I mean, you've got to eliminate all that stuff first, and then you can start looking at, you know, if it still doesn't work after that, you can then start looking at different diagnoses. But you won't, you know, you can then essentially rule out the capacitors as the problem. Another thing I should really mention here, because I do recap a lot of computers, whenever I recap a computer, if there is a problem with it still, if it's still failing, one of the first things I check is my own work. And I kind of get a bit frustrated with that when I see people jump on and they've recapped their own computer and they put a picture on Facebook and they say, oh, I've just recapped it and it's still not working. And I sort of feel like, you know, you have got to check your work. I mean, I check my work and I've recapped hundreds of these things. It is the most likely, you know, cause of a problem. You know, you put in the human element, that's the most likely cause of a problem. You've made a mistake, you've accidentally created a short. You know, I mean, I see a lot of people that, you know, do recapping with through-hole capacitors, you know, radial caps instead of surface mount caps. Now, obviously, when you've got those pins and you've bent them out and stuck them on the pads, I mean, that's a really, really easy way of causing damage to traces and pads doing that. And so, you know, my recommendation to anyone who's doing this, if they've recapped and it's still not working, the very first thing you check is your own work. make sure you have a multimeter. Go around and test. So if I had a component on here, you know, sort of test from the pin to this little via down here, via up here. You know, you basically look at the pin, you trace where it's going, and you grab a multimeter and you test from the pin to where it's going, and you just check, make sure that you've got continuity there. It's so important. I mean, you know, people make mistakes. You know, I'm not going to go around and say that every single recap I do is perfect first time. Every now and again, you might make a mistake. Sometimes it'll be like something silly. Other times it could be something that's really hard to find. As I mentioned before, when you're putting tantalum capacitors onto these that have big wide pads on them, pins on them, sorry, and you're putting them on these thin electrolytic capacitor pads, it's really easy for a pin to hang over the edge and accidentally create a short. That's always one of the first things I check. If I've done a recap but it's still not working, I'd go and check and make sure whether I've accidentally created a short. It's just, you know, it's just how you have to do it. Do people buy these from eBay and bring them to you, or are your clients bringing their once used Macs back? What's the split between new classic Mac owners and old ones? It is a combination of both. So, for instance, I think this one here, yeah, this one here was one bought on eBay. I'm pretty sure, David, you can confirm, but I'm pretty sure that was the story, that it was bought recently on eBay and didn't work, and of course when opened up, there were things weren't plugged in. There's no hard drive in it. You know, so it looked like someone had a bit of a fiddle. And then, yeah, some of them are ones where people have had something stored away in their cupboard for years and years and years and years, and they pull it out and they try it out and it doesn't work, and then they bring it to me. So it's, I don't know, it's I don't have the kind of stats on what it is, but it is definitely a combination of the two. It's people that, you know, might be reliving a bit of nostalgia and they've bought an old one on eBay and it doesn't work. Or it could just be that, you know, they've had it sitting on a shelf for years and years and years, and then one day they suddenly go, you know what? I want to pull out that old Mac and have a fiddle. See a little bit of pitting there, but it's only just on the very end of that pad, so I'm not too concerned about it. 5-volt curse. Machines from various sources, and I bring a lot of them to Bruce. Yes, there is, you know, at any given time, I've usually got at least one or two of Madeline's computers here. So, the Mac Pro that I have here at the moment, I'll be very happy when that's gone. That takes up a fair footprint in this house. My wife will be very happy to see it gone, that's for sure. When is that computer going? She says to me. Yes, I know. That is something that's very important. I mean, you know, from my perspective, when I do get certain Macs, different types of Macs, you know, interesting Macs, I love getting them because it gives me an opportunity to do a live stream. This is one of the reasons why I'm glad there's a Quadra 700 coming at the moment, because people do like the Quadra 700. It's a popular Mac. Okay, so we are now on to these three that are right next to the plastic. So I do need to exercise some caution and make sure I don't melt anything while I'm doing the cleanup here. Then, of course, we've got this little bit here, which I mentioned before, which is kind of like a burn mark. But I'm hoping that once this is all cleaned up, that won't be anything too bad. I just melted something. The soldering iron touched something on the way through. Whoops. Okay. All right, so let's continue with our cleaning up here. We're getting fairly familiar with this process now. These are some grubby ones here. I think I need a bit more flux. It's the stinky flux. I'll mix the stinky flux. Something's making beeping noises. I don't know what it is. It's one of the devices I have here. It's just making a constant bzz, bzz, bzz. And it might be my new solder suckery thingy, because I don't recall hearing that noise before, and it's the only new device in here. Okay, let's just check the chat here. Oh my goodness. So chips above the RAM. My board started working. Thanks for the tip. Excellent, excellent. That's really good. So that's the socketed chips. Oh, okay. Yeah, I mean, they're also part of the display. Those socketed ones. I mean, yeah, I mean, sort of reseating those could help. SC30 is definitely one of those makes I want to have an SE, but it needs repairs. Yep, yep. The incidentally, Scarlet Swordfish, thank you for your contribution to our folding at home Maciac team. I see you on there, adding to our CPU computing team. It's great to see. Yeah, so the Quadra 700 is an interesting one. There are a few good things about the Quadra 700. One is the fact that it doesn't have any surface mount electrolytic capacitors. It only has tantalums on there, in place. So they typically don't end up with capacitor problems on the logic board. However, they do often end up with problems with the power supply, and they do often end up with problems with leaky batteries. But it's really interesting because I used... It's not really interesting at all. It's just another one of my anecdotes. I worked in a design studio at the time that they came out, and I remember that moment, that transition, when we went from 68030 Max to 68040 Max. We got some Quadra 700s, and I think we got an 800 as well. Does that sound right? Interestingly enough, they ended up getting stolen. Yay! But when the insurance paid out, we then got some new ones, and we got, I think, an 840 AV or something like that. I think a 660 AV. Can't remember that. Things had got a little bit faster between when we got them and that. But anyhow, so I have a lot of very major nostalgic associations with the Quadra 700, because I mean it was at a time when I was using these computers at this company a lot. And they were just so much faster than the old Macs we had there. Up until that point, we'd been working with SE30s, 2CIs. We had probably a few older ones there. I think we might have had a 2CX there as well. But I'll tell you what, that jump to a Quadra 700 from going from a 2CI, wowzers. I mean, that was big. It was a big deal. So, yeah. Now, what's wrong with this picture? I'll give people a few seconds to observe what's going on here and see if they can point out what I'm going to be having a look at next. there's a delay between what I say and what gets put into the chat. But you know, I'm looking for some spotty traces. Scarlet swordfish wins the turkey. So okay, so let's have a look and see what these spotty traces look like, because you probably can't see it on here, but they really do look quite indented. So I have real concerns that they are all the way through. Now I'm going to get rid of this black spot here first, just to see what's going on, and then we're going to have a look at some of these little spots along here. Going to have to. If you're wondering why they get spots on them, is because the leaking electrolyte lands on them, and then where the electrolyte, little bits of electrolyte have landed, it kind of eats through there. I need to move a bit here, sorry. Which way around am I going to go? I'm going to try and get a good angle on this for the scrapage. Yeah, I mean that trace is broken. There's no way that would still be making contact. You can see there's that quite deep pitting in there. So we're going to need to do some trace repair on that. But that's okay. That's what we do here. And I feel the same about these ones here. I feel like they're not too crash hot. Not too crash hot, eh? Look at them all. We got some trace repairs right next to the plastic. But the important thing is that we see these now. We fix these now. It gives us a much better chance of this thing actually working when I put it all back together and whatnot. There is a possibility this may extend into a two-stream repair. You know, I don't necessarily want to do a Mac 84 Steve style stream that goes on for hours and hours and hours and hours and hours and hours. That's probably a little bit unfair to the viewers. Not saying that what Steve does is unfair to viewers at all. I'm not saying that at all. But I'm just not too keen on going for that long. Right, so here's the thing. Here's the thing I have to consider. I've got a trace with a dot right up hard against okay, I'm skipping over the stupid stuff. I'm just not even 11 p.m. It's Friday. Go for it. It's not Friday. It's not only unfair, it's cruel and unusual punishment. Bear in mind that caked. So I have this kind of desire at the moment to remove this plastic connector and then put it back on later, because there are traces, you know, going under it, and I've got spotting on all these ones here. And if there is a busted trace under this connector, I suppose I could always just run a wire. I could probably test it, actually, can't I? But you know, that other part is that, you know, if it's got spotting on it, it might, you know, it might get worse. I could take a viewer poll and say, who thinks I should remove the connector? Here we go. Scrape a little bit through. Is that it, you reckon? Or is that it? I don't even know where that trace goes, to be honest. I mean, I think it might be this one, but I'm not getting any beep. So, okay. All right. With that fancy solder, okay. Plastic sucker needs to be removed. Yep. Okay. I'm called compare person I've never encountered an Amiga person. I've always been curious why they had such a legendary reputation. The Amiga. That's a very interesting thing to bring up because I have recapped a couple of Amigas and I even own one, thanks to Madeline. I own an Amiga 500, but they don't need recapping. The Amiga 1200s do, and the 600s and various others. They have a really loyal following, the old Amigas, and I have to say, if you were interested in playing games back in those days, the Amigas were amazing. There were just like arcade games galore that you could play on. I think they were actually quite a good sort of gaming computer. But yeah, they just sort of fizzed out. But I can definitely see the appeal. I can see why people really like them. Okay, so let the owner decide. Yes, okay. So where is he? Is he still in the chat there? So David, what do you think? Do you think I should remove this plastic connector? Remove. Yes, okay, there we go. There's got the green light now. So once again, I'm going to have to go onto this side view here because there's not much you can see through the microscope with this. It's a little bit difficult. There's my UV light out of the way, and there's my cheat sheet out of the way. There's my messy desk, which will remain that way. Now these are, oh, actually I was going to say these are quite big pins, but they still fit, so I think we should be fine. The thing is that these have different sized tips on them with different sized holes in the middle, and I have 3 different sizes here, and you need to obviously make sure that the pin of whatever you're desoldering fits through that hole. If it doesn't, this ain't going to work. But you want it to fit as snugly as possible so that it's focusing that sucking power in the right place. I mean, I might need to empty this because it could well have a lot of solder in it. Guess what I don't have on? Don't have on my glasses. And I don't have my light. Okay, so well, that did quite a good job. Now, anyone who's ever removed a whopping great big connector before, using wick, using a manual solder sucker, will be looking at this at the moment and going, that's pretty cool. Because the amount of time it takes to do what I just did, if you were using wick, or sorry about the boof on the microphone there, I just went boof. I can't see properly with these glasses unless I'm up real close. So probably better. Yes, this is my feeling as well. Is that that the if we don't remove it and have a look under it, who knows what's going to happen in the future. This is me just adding some more solder to a couple of those pins there, because 2 of them didn't come out. Sorry, I keep banging the microphone as I grab this thing, and I apologise for that. Okay, that appears to be all of them. Now let's see if I can get this connector off now. Let's have a look under the microscope here, because I just want to show you what it looks like now, because you can't really see. Yep. Focus. Where is it? I've lost it. Oh, there it is. Can't really see what I've done here, just sort of like without a bit of microscope action. So what I'm wanting is these to be kind of free from the holes. So I'm just giving them each one a nudge here with the iron. Make sure it's not stuck on. There we go. There we go. Come on. Come on. Okay, now I'm hoping this will come off now. So let's see. Give it a bit of a wiggle and a waggle, and out she comes. So once again, if you are someone who has ever removed something like that before, just with a soldering iron and a sort of an old-fashioned solder sucker or a bit of wick, you can definitely see the appeal of having one of these devices here. Hello, Nate. Welcome to the stream. Right, okay. So, I better focus this. And down we go. Okay, so the one that was under, I'm just going to give these a scrape here. The one that was under, well, it looks like, were there two under? Yeah. We definitely do have some holes. Not sure if they'll need to be replaced, but so that one was going from there to there. That one, okay, that one goes down to this one. So I can at least test this now with a little bit of a beep and a beep. And a beep. We all hear that beep? So we're going from this one here to there. Okay, good. Well, we had continuity with that one, so we're okay. But I am still going to... that one was actually fairly clean. But having said that, this one here below it is extremely not clean. And so this does make the work that I'm going to do now a little bit easier. Look at that glob of solder there. So let's just go in and get some wick, which I keep losing. And we'll add some fluxaroonie. And we'll get some solder on the end of the iron. And then we'll get our trusty wick. And we'll keep scraping. Okay, BRB from Jay. See you when you get back. Once again, we'll just be killing time. I'm not going to do anything interesting while you're not here. I know there will be repercussions if I do. Right. So, let's do some testing here with my little beepies. And let's just have a look and see how bad this is. There to there. No beep. That one's beeping. That one's beeping. That one's good. Not good. Not good. Not good. Yeah, there's a lot of not good on this board. So there's a few trace repairs there. David's looking at the stream now going, oh my god, what's this going to cost me? I'm just looking at it thinking to myself, how on earth am I going to do all this in one stream? Right. So let's do some cleaning here. We've got a lot of cleaning to do here because I need to really check this out. Have I now got green stuff all over me? I have got some green stuff on me. Oh yeah, little light has fallen off here. Right, so I think what I'm probably going to do, I'm probably going to end up doing this stream in two halves, or two pieces. I will look to probably finish this off, you know, sort of on another day. It'll probably need to be another day, because if I do it later in the day Australian time, it'll probably be a little bit too late for anyone who's joined in US time. But So the problem that I have is this: I've got these traces to repair, and I don't want to, I've got to do them before I can, start this up. There's just no point in trying to start it up without repairing these traces, because we know we've got quite a few that don't make contact. So so I have to repair these traces, and then what I'm also going to want to do is I'm going to want to coat some of these with UV solder mask before I put the replacement components on. If we look at some of these areas around, sort of around here, I'm going to put a new component on here. Well, I've got to repair this trace, and I've got to coat it, and then I've got to plonk the new component on there. And this component's going to have to probably sit a little bit that way, because it won't be able to sit flush. So there's a little bit of work to do here, and there's drying time and all that sort of stuff. So I am not sure that I will be able to get this all into one stream, but I can at least get a few of these things done. But we may have to have another one that involves putting the caps on and testing. So about to cross the 1 hour mark. Only 7 hours to go. Yes, I mean I'd 2 hours. I started at 11, so it's 2 hours, isn't it? Sure, it's 2 hours. I think. Yeah, it's definitely 2 hours. Yeah. So there we go. Just going to get some solder onto these. Whoopsie. A bit more scraping here. Just want to clean up this little via here a little bit. I didn't like the look of it. For those that aren't aware of what a via is a little tube of copper that goes through a hole in the PCB, in the printed circuit board, and it takes the electricity to another layer of the board. Now that might just be a matter of taking it from the top to the bottom, but in a board like this, I think there are 4 layers. So there's a top layer, a bottom layer, and 2 in the middle. There might even be 5, but I think it's 4. And that little via is potentially taking that power, or that signal from the top layer to the middle one. So it could be going from the top to the bottom to the middle, wherever. So this is one of the things with these boards. I mean, what we see is we see the top. You can flip it over, you can see the bottom, but there are actually layers inside it that you don't see. And that's why it's so important when you're doing repairs to have schematics, because it's not just a matter of following the trace where it goes. Sometimes the trace runs along, gets to a via, and then you have no idea where it comes out. And you can sit there with a multimeter testing where it comes out, but that's no good if you've got a board that's faulty, because who knows, it could be broken. You might never find where it's meant to be connected up. So, anyway. Right. Right. So, I'm giving up on this is the UV mask that I put on before, and as you can see, I've squished it with my fingers. So what I think I might end up doing with that is I'll clean it and I'll paint it on again, and I'll do a nicer job, because I'll let it dry before I'm fiddling with the board again. Green, 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 green. Green. All right, so let's start looking at some trace repairs, because we know we've got those to do. So we've got a few that I'm going to do here, and I'm just thinking, I think I'd like to stick this component on first before I start the trace repairs, because I'm worried that if I do the trace repairs, when I put this one on, I might damage the repairs or push them out of the way or whatever. The capacitors, I'm not too concerned. They're a lot easier to put on, but there's a lot of sort of moving around and everything when you're putting these components on. So let's just grab this chip, which I removed earlier, and that's here, and we'll just have a look at that under the microscope. This is the underside of it. This is referred to as a what's a PLCC chip, something like plastic leaded chip carrier, I think they call it. And it's got these little curved pins that curve around underneath the casing or whatever, the carrier. package, they sometimes refer to them as. These can either be put into a socket or they can be soldered directly onto a board surface mount. And then in this instance, this one is a surface mount one. And what I'm going to do with this now is I'm going to try and clean it up a little bit. So I'm going to grab a whole stack of solder on the end of my soldering iron. And then I'm going to try and hold this chip still with my tweezers. And I'm just going to, I've got all this flux sitting on here. I'm just going to rub around there. Just looking to get all of these bits looking all shiny again. It's looking good. Then we're just going to get that solder off. So we grab our wick. Wickety whack. And just remember, folks, if you're wanting to buy some wick or anything else that you're seeing in this video, there are links in the description. They will take you to Amazon. And from there, you can make your purchase. And I get a little bit of money. Not much, just a little bit. There we go. Now I'm just going to get a toothbrush with some isopropyl on it, and I'm just going to gently clean off some of that flux. There we go, and that chip is all ready to put on. I would say it's like a new one, but it's not. But it's certainly cleaner than it was. Then we're going to put this on here. Now, I noticed someone on a live stream recently had to attach one of these and completely and totally ignored my advice about how to do it. So I'm going to go through this process again for the benefit of that individual. I'll get my nice flux. I don't like this flux. Here it is. There's my nice flux. Put some flux on there. And a chair as well. Right. So, now, with PLCC chips, there are two ways of detecting the orientation. Way number one is this little bevel on the edge. There are 3 squared edges and 1 beveled. You've got a bevel edge. The other is this little indentation here. That indentation indicates that is pin 1. And then you go in a counterclockwise direction. Pin 1, pin 2, 3, 4, 5, 6, 7, etc. So that is your pin 1, and that is your little bevel. When it comes to placing these on the board, usually both of those things are indicated. Here is a white dot to show where pin 1 is. There is a white dot to show where pin 1 is. And here is the little stenciling here showing where the flat edge is supposed to go. So let's just plonk that on here. And what we need to do is we need to try and get this as aligned as possible, keeping in mind, of course, this has 4 sides. And you can't just get one pin aligned, you have to align every pin on every side. Now, generally the way I do that is I start at one corner first, and then I go to the other corner. So what I'm looking to do with this, I'm trying to get this lined up as best as I can, like that. Okay, he's pretty much where I want him to be. Then I'm going to get a little bit of solder, and I'm going to put that on the tip of my soldering iron. I'm then going to grab some tweezers, and I'm going to hold this component still as best as I can. And I'm going to solder 1 pin, just the one, just there, just one. Then I'm going to spin the thing around 180 degrees from where we were before. And there's my soldered pin just there. And then I'm going to solder a single pin from the other side. And I'm going to choose this one. And there we go. And we've got 2 pins. Now, what we've got now is we have this component tacked on at either a corner so that it's not going to move anywhere, and then we can start soldering the other ones. And we know it's all lined up. So just grab some solder here and do a little bit of drag soldering. Like that. They're all joined up. Then do some more spinning. And I've been looking at the chat here. Okay, that's all right. I didn't need to look at the chat. There's very little chat going on. I know why. People are just so fixated on how fascinating this is. Okay. No, I'm kidding myself. I know that. Okay. Come on. What's going on there? There we go. And then the last one here. So that is now connected up. What we like to do now is check to make sure that all the joins and pins are all looking good, and there's no what do you call them things? Let me just scroll out here. So what I'm doing now is I'm moving my microscope so I can put these underneath here and look at the pins, and I'm looking at those from an angle here like that, and I basically just want to see that they've got nice smooth joins to those pins. So, and there's no bridges. That was the word I was looking for. As you can see here, I'm slightly off kilter. I'm a little bit to one side, but that's okay. It's still fine. And then let's look at the other edge. No bridges, all joined up, looking good. Last side, it's a lot harder to get to this side. That's close enough. There we go. We can see that they're all joined up, so that's looking good. So happy about that. Now we get white out, and then it adjusts. So, incidentally, if you're having a look at this and you're thinking, oh my goodness, there's a component missing, it's meant to be. Yeah, that's meant to be sort of blank like that. Look at these pins a bit. These are the speaker pins, and it is quite easy for these to get bent, in particular if someone tries to take the board out and doesn't realise the speaker is connected. They then get bent when you yank it. So, unbent. So you put the solder down on the pads with the wick, and now you're just reactivating it. So when I'm putting the solder down on there, all I'm really doing is just putting an incredibly light surface of solder on there. It's just really just the thinnest of layers on there. But that then provides a really good surface for the new solder to attach to. So are you adding more? Yes, I'm definitely adding more. So yeah, the sort of scarlet sulfur makes a sort of a good point here. With a lot of surface mount components when you're putting them on, what some people do, and I do this for certain components, but not for all. What some people do is they actually put a little mound of solder on each pin, and then they put the component down, and then they use a hot air station to melt each of those mounds, and then just let the component then sort of settle into that little mound of solder that's there. Now, I definitely do that for certain components, but when I'm dealing with these components, I much prefer to start off with essentially a completely clean pad. So as I say, it's just got a very, very thin layer of solder on it, and then so that's just to help the solder attach to it. But I start essentially with a clean pad. I put the component down, and then I add new solder to it. So that's how I like to work. So right, now what are we looking at here? Is it epic thriller that I feel more like a watch? That's right. Yes. Well, I mean, look. Yeah, it's. I guess the one advantage you do have at the moment, sort of, David, is that the patient is currently dead. So I can't make it any less dead. So, but look, it's not good. I mean, I will say that straight off the bat. What we're looking at here is not pretty, but I'm feeling reasonably confident. I don't often get defeated by these things. So now we need to do some trace repair, and to do some trace repair, we need some wire. And if anyone who's watched my videos before knows that I do my trace repair with enameled wire. I buy it in spools like this, spools like that, and this is enameled wire of a particular thickness that I can't remember. 34 AWG this one is. This is the one I'm going to use. This is a nice combination of thinness, which makes it easy to work with, but thickness meaning that you won't lose it. You know, the really thin stuff is quite hard to manage. And so this is what I use, and it is enameled, which means it has a coating on it, which means that if it comes in contact with another piece of metal, it's sort of insulated. But that insulation comes off very easily with just the application of some heat from the soldering iron, so then it makes it very easy when you might want to make a join. And I will demonstrate this here now. So I need to run, I'm going to put a trace along here, I'm going to repair along here, and I'm going to run it from there, across there, and then up there. I'm probably going to start at this point here. Just going to clean these tweezers, they're a bit dirty. So I'm going to probably start here. I'll run it along there, and then up there. And then we're going to obviously do the same with this one. And this one, maybe a bit of pitting there. Yeah, I mean, this one I think is okay, as is this one. I think it's just this one, this one, this one. I'll just do these three. I mean, even that middle one's not too bad. Maybe we can test it. It's tested. Ah, it's off. Yeah. Always recommend checking to see that your multimeter is on. Yeah. Okay, so look, I'm not going to worry about that one. And to be honest, even this one, I'm sure, is making contact, but I just don't like the look of all of that blackness there. Don't like it. Right, so let's get a little bit of this wire, and we'll start our trace repair process. I usually start with a piece of wire that's a lot longer than I need, and we get some flux and pull flux. There's already a fair bit there, but I want more. And then I'm going to get some solder onto the iron. It's just me there doing that there. You're not seeing that on camera. I apologise. Then I need to find a way. Because I am right-handed, I like to use my soldering iron with my right hand, but then I use my left hand to hold the replacement tracer in place. So I want to put him there. And then I'm going to apply some heat. That heat is going to melt that coating off that solder, off that wire, sorry. And then that's joined. So that wire has now been joined to that trace. I've got a little bit of excess here that we don't need. I can just cut that off with a scalpel. How's the focus there? A little bit out. Okay, let me just check here. There we go, that's better for me. Because, you know, as much as I want you guys to be able to see this, I need to be able to see it too. So a little excess off there. Okay, now that's me just moving it by accident. Sorry about that. Now what I want to do is bend this to follow the contour of this trace. Just looks nicer doing it this way. I mean, you don't have to do it. I could just run this straight to it. But I just think it looks nicer if you follow the contour of the original trace. I feel like it's just a neater job. Grab some more solder onto the end of my soldering iron tip. I haven't changed the size of tip on this. I could probably go with a slightly thinner one, but you know, there we go. I do like using this one. That one was completely out of camera. Sorry. And then we're going to bend this one up to there. I could probably run this all the way to the pad there. We'll see. I may or may not. I'll just decide whether I want to. And then we hold that in place there and apply some heat, some solder. And there we go. We've got a lump, 8 lumps. There we go, lump gone. And then I can always just bend this around and push him into that. Look, I made a bridge. Too much solder. Okay, then I'm just going to trim off the excess of this wire. So I'll just grab that there and chippity chop like that. Okay, and there is our first little trace repair. We'll get rid of that little stray piece of wire. He ain't going to do nobody no good. Like that. And so we just, from there, along there, and around. Sorry, I haven't been looking at the chat during that. What are your thoughts on tip thinner as compared to just using solder? Tip thinner. I've heard of tip. I've got a tip reconditioner thing. I'm not sure about tip thinner. Yeah, I mean, I'm quite happy with what I use. One of the things I should really mention, you know, I've seen a few sort of streams and other people having comments where they're having issues with their tip not taking solder anymore. And I have found tinner. Yes, okay, tinner. Yes, so I have some floating around here. Yes, tinner. Yes, look, it said tinner. I read thinner, so nothing wrong with me. It's only my native language. So I have found that using these to clean your tips, these are these sort of little copper mesh balls, and also regular use. I mean, I find that if you're not using a soldering iron very often, you're just letting it sit there, the tips can oxidize and get harder to work with. But I find that if you've got a good quality tip and you're cleaning it with these, they stay lovely and shiny and really have no issue with them at all. I don't have any issue at all. Having said that, my older soldering iron, I used to have nothing but problems with the tips. But in those days, I wasn't soldering as often. So I think the tip was oxidizing and going bad while I wasn't using it. And the other thing was I was using like the wet sponge to clean the tip with, which a lot of people swear by. They say, you know, they use the wet sponge to clean the tip. I don't use the wet sponge. I use these little sort of mesh steel wool ball thingies. I mean, is it copper? I don't know. It looks like copper, but I don't know if it's actually copper. So that's what I use, and I find that works really well for me. And I've never, with this soldering iron, I have never needed to use tinner on these to, you know, like try and recondition the tip or anything like that. Okay, so now let's get back to this, because I'll tell you what, if we keep going the way we're going, I mean, it is just going to take forever. Right. Right, so this is the one here which we know is the most important one for us to fix, because it is, oh my goodness, what? In the words of, was it Stewie Griffin? It is a casserole of nonsense. Right, so doing the same tip here, same trick that I did before, applying some heat, melting off the coating, and soldering onto the trace. Now, I'm not particularly happy with that one, but it's okay. It's held in place for now, and then I will just go to the other end. And let's get some tweezers here. Hold that in place and melt it. Keeping in mind, of course, I've already got a trace repair right next to this. I need to be careful that I don't get the soldering iron so close that I damage what I've already done. Now I'm going to bend this down. And I'm just going to get a little bit extra onto here. Looking good. Looking good. And then I just want this. There we go. Not too far. Not too far. There we go. Oh, not too far. Oh. Come on. There we go. That's pretty good. That's a pretty good. Yes. It's a good. It's a nice. I'm just being super careful here, because just being mindful of the fact that he's a bit messy around here. Get some alcohol on here and just gently scrape it with a toothbrush. I have to be super gentle now because these are poking up. Now, of course, when I have finished this, I am going to coat these repairs in a UV solder mask, so they'll be well protected. They'll be as safe as houses. There's no risk of these ever coming apart in the future. And of course, the other thing to remember is when I finish this, this will also go into the ultrasonic cleaner and get a lot of this gunk away. So that's a good thing. Right, so there's 2 traces repaired there. Now we've just got all the fun and games of these ones to do. Right, there's no point in putting this off. Okay, was this? Okay, so just spent 20 minutes on the same effing hole. I need that automated solder sucker. Yeah. It's you know, look, it's an additional cost, but if you're doing a lot of this stuff, it's definitely worth it. Okay. All right. So let's continue here. We have more trace repairs to do, and it is, as I said, with the capacitors, it's a lot of repetition, and so I'm sorry about that. I may end up giving this board a clean 4i UV solder mask it, and then I'll put the components on, and then actually I don't know what order I'm going to do this in. Thinking about it now. I definitely think the board's going to need 2 cleans, because I think I'm going to need to clean it once before I put the UV solder mask on, and then I'll need to clean it again once I put the new components on. So, there's one, and there's that. Going to head off. Keep up the good work. Thank you for joining Scarlet Swordfish. I do appreciate it. Okay. How are we doing here? I'm just going to check, see if people are dropping off. Oh, I've got 21 viewers still, so I've actually only had like a drop off of 1 or 2 from my peak. So that's nice. Thank you everyone for staying with me. Okay, now this one is a bit spotty as well. I mean, I might be going a little bit too far with these trace repairs, possibly repairing ones that don't need it, but I just don't like the look of them. And there's nothing worse than doing all this work and then firing up the computer and it's still not working. Is this the worst SE30 you've worked on? No, it's not. It's a shame I don't have some pictures to show of that one that I worked on. There was one I worked on which was just unbelievable. The amount of corrosion damage was extraordinary. Down. Stay down. Thank you. Yeah, I did one, and it had burn marks all over it as well. I can't even remember what happened to it. I can't remember if I fixed it or not. I think I did. But yeah, I mean, they do have problems. There's no doubt about that. And they're old, you know. I mean, these are a really old computer. I mean, they're someone can correct me if I'm wrong, but they were probably one of, if not the first, of the Macs to use surface mount electrolytic capacitors. I know that the Mac 2X did, and the later version of the Mac 2 board used them. In terms of the actual chronology there, I'm not sure exactly which ones came first, but yeah, they were certainly one of the first Macs to use surface mount electrolytic capacitors. And at the time, I thought they were doing. I'm sure they thought they were doing a great thing. But who knew they were all going to start leaking? Now, I know there's a lot of repetition in here, but as you can see, it does move quite quickly once you get into the swing of it. You definitely do get into the the swing of doing these trace repairs, and then you suddenly look down and you think, oh, I've done them all. If anyone does have any questions about what I'm doing at the moment, please let me know. Obviously, a microscope helps with this sort of work because I can just see this so closely, and of course there is the fact that I can watch the moment solder goes fluid compared to when it goes solid. When I heat it up, when I can see that it's molten. But I mean, what are we? 3 down, 4 more to go. So we're nearly at halfway. There's no battery leakage. I was so convinced I'd open up, find a leaked PRAM battery. It's one of the worst things in the world when you see that. I mean, I've repaired a 2VI that had battery leakage. It wasn't as bad as some battery leak computers, but it was still bad, and there were damaged traces. I've got a board here over my left shoulder, which is a 2VX that's had battery leakage, and I have already spent probably at least 2 or 3 hours on it. It still doesn't work, and I don't know if it ever will. Again, it's very sad. I hate to see it, and I do like to try and fix them if I can. I've had in here right now. There's 3 boards. There's a 2VX, 2SI, and a Mac Classic board that are they're damaged by battery. Oh, and a Color Classic for that matter, floating around here somewhere. That have been damaged by battery leakage and are just absolutely beyond repair. There's just nothing you can do with it. You can just sort of, play the last stand and move on. Because they're just, there's just way too much damage. When, the battery damage gets in there, I mentioned before when I was talking about vias, you can be in a situation where you can't see the damage anywhere. One thing I will say about trace repairs on these older Macs, the traces are bigger. If you were doing this with like a modern MacBook or something like that, well, for starters, you'd be using a much thinner wire. But I have done a few trace repairs on like a MacBook Pro, and on a few MacBook Pros for that matter, because that's what I started off doing before I started doing these vintage Macs. As soon as I see my solder is not, if I'm getting little peaks in the solder, that's when I start adding some more flux. Yeah, when you're working with the more modern computers, I mean, it's a lot harder to do trace repairs because they're so much smaller. Rounds spent on some machines, it's best to forget and then just try again later. Yeah. There has to be a certain point, in particular when I'm doing this for other people. Okay, if I'm just doing it for my own sort of fun, my own computers, it's like spend as much time on it as you want. Spend a weekend on it if you like. But if I'm doing these for other people, there's a point where I have to decide what's going to happen. First of all, am I going to charge the client for the amount of time that I've spent on it? If I am working on like a battery damaged computer, and I've spent 6 hours on it trying to repair it. Oh, this one's giving me grief. Stop it. I've spent 6 hours on it. Let's just come up with a figure for an hourly rate. I don't know, just for the sake of easy mathematics. Let's say it's $100. Okay. And incidentally, I'm my main trade. What I do for a living is I'm a computer programmer. And not sort of being sort of boasty or anything like that, but computer programmers can ask a reasonable amount of an hourly rate. But let's just say, for argument's sake, we're using the number of $100 an hour for doing computer repair. So let's just say I spent 6 hours on a repair doing it. Well, there's $600. You know, and who's going to spend $600 on a computer of this age? You know, or let's even halve it. Let's talk $50 an hour. That's $300. I mean, even that's ridiculous. You know, I mean, it's just not doable. So what you end up doing, you end up sort of either, you know, just giving up and walking away and not bothering to repair it, or you end up charging essentially what becomes like a charity, because you are charging way below like a reasonable hourly rate for the time that you're spending on it. So, you know, I mean, it's a difficult thing, you know, from my perspective of wanting to try and repair as many of these computers as I can. But then at the same time, you know, I've got to remember that it's my time, and you know, sort of what's the best way of dealing with it. So anyhow, that's sort of gone on a bit of a tangent there, but that's an issue I face a lot of the time when I'm working with these old Macs. Part of me really wants to get them fixed. I don't like the idea of a computer not being fixed if it's one that I know I can fix, or if I think I've got a good chance of fixing. But then at the same time, I mean, you know, my time isn't free. If I'm working on this and I'm not working on something else, you know, I'm losing money on something else. So it just has to be a kind of a balance. And then, you know, there are times where I do feel like I'm actually doing a service if there's a computer, you know, like an old computer that you know, sort of you want to keep going. That's part of, like, I guess, restoration, isn't it? You know, I mean, it's why do you restore an old car? You don't restore an old car for profit. I mean, you could try, but it's a waste of time. I mean, you know, sort of number of times that people end up selling cars that they've restored and saying, hey, I've spent this much on it. It really doesn't matter how much you spend on it. It's irrelevant. Absolutely irrelevant. That's not why you restore things. You restore things for the love of it. Okay, well, I said before that we were nearly there, but we weren't because I forgot about this one down here. So let's continue. That shall. I might spin him around. I can get a bit of scrapey here. It's going to be interesting when I come to put these capacitors down, because I'm not left with a whole lot of space around all these trace repairs. Do I have the skills? Who knows? Only time will tell. I've used a lot of wire on this. I mean, it's a tiny amount, but you know. How's everyone going? They're still enjoying this? Or are you all getting bored out of your brains? You're all doing other things. Watching TV or having your dinner or something like that. I know when I sit and watch other people's streams, I often end up doing other things at the same time. I quite like watching an occasional Paul Daniels stream when he's repairing Macs. I do like to watch his stream from time to time, and I do like to watch an occasional Rossman's stream. That is when he's fixing computers and not doing other silly stuff, like riding his push bike around New York or something like that, or talking to his cat or whatever. Not that I have any issue with cats. I have 3 of them. And of course, one cannot forget all the time we spend watching Mac 84 streams. They have got to be our favourite. For those who might be watching this who have never watched a Mac 84 stream, jump onto Mac 84 and subscribe, because he does, well, I'll tell you what, when he starts a stream, he gets into it, I'll tell you. He's not going to look at what he's doing and say, you know what, I can't fix this today. I'm going to come back and do it tomorrow. He's just like, okay, I'm going to download this thing here, and this should make it work. And he keeps going, and he keeps going, and he keeps going, and he keeps going. And I tell you what, you've got to have nothing but praise for him when he's doing his streams. He does always want to achieve his goal, even if it takes him 7 or 8 hours. Okay, what do you do? Okay, so have you ever fixed a nick in a trace by just dropping some solder over it? Yeah, I have, but it's got to be a pretty small nick. It's quite difficult to get like a blob of trace going across a little gap. It seems like it should be easy, but when it's this narrow, you know, you've got to get a reasonable sized blob to get it to move across, and it's quite hard to do. So even with quite small gaps, I still might use a little bit of wire just so that the solid's got something to adhere to. Okay, working on that iMac G5 PSU because I'm sitting in a yes, I'm having a good time. Good stuff. Good stuff. Okay. I would never say stubborn to a fault, Steve. I would never say that. What's the word? Determined. That's the word. Open transport. Yes, we don't know what the problem is with the open transport there. Okay. What you replace all of the RAM on 128K motherboard? Feels like I'm not alone in myself. So I've got a question for you, Jeff. You're replacing all the RAM on your 128K. Are you just pulling out the old RAM and putting new RAM in, or are you pulling out the old RAM and putting sockets in to make it easier to replace it in the future? Okay, good night, Krishna. Thanks for joining. I do appreciate that it is getting fairly late in that part of the world. This is one of the reasons why I am going to turn this into a two-parter. I think the second stage will be the putting it back together. I think I'll do this last trace repair, and then I will probably wrap it up after that. After my normal banter, I will then pop this into the ultrasonic cleaner, and then I will. Those may notice that when I just did that, I just lifted another one of these trace repairs off. There we go. Stay down. Stay down. Got my tweezers around the wrong way. There we go. Look at this. Got a cascade. Fix one, wreck another. Need some more solder on that. Wouldn't you say? Okay. Stay. There we go. Okay. And then this one here. With these being so close together, can I tell you what I really should be doing here? I should be taking out this great big fat tip of my soldering iron and putting in a little skinny one. Like this one. This is my second most used soldering iron tip. The other one I had before was my first mostest. Sockets. Okay, yeah, no, that makes sense. I mean, it is definitely the way to go. Once these traces have been rebuilt before applying solder mask, looks like you have found your new channel art photo. Good idea. I like it. As to whether I can be bothered, that's another story. Oh, look, that's a little bit too much solder on there. So this is also a bevel tip, but it's a much smaller one, and I'm hoping this will make this a little bit easier for me. And it's not. I'm having exactly the same amount of trouble. Okay. There's that. Let's get rid of that. I've just got to get rid of this little bridge here. Like that. All right, and then we have the last one. All right. Lay them down. Yeah, I generally don't tin them before I lay them down. I just find it easier the way I do it. Okay, well that's it for the trace repairs. I'm going to go back to my normal tip here, and I just wanted to just because when you're looking at this through the microscope, you can often lose a little bit of perspective. So what I'm going to do is I'm going to do this, and I'm going to remove this little UV light, and I'm just going to show you the area I've been working on. So I'll just give it a quick little brush with the old. Okay. So the trace repairs that I've been doing have all been focused on this area right here, just at the end of my finger there. You can see where you can see a little bit of copper colouring. Let me get some line onto it. You see the copper colouring at the end of my finger there. I know it's not super in focus or looking awesome. Hey, wasn't talking to you, Siri. And I'm still not talking to you. Shush, go away. So that's the trace repair there, and then the others are over here. So I'm just showing you that because it's very easy when you're looking under the microscope to just go, oh yeah, okay, there they all are. But when you see them sort of like back a little bit, you get quite a different perspective on scale. So that's all of them there. Oh, all of them there, along there. So I'm just going to get rid of the solder here without getting rid of solder on those traces. Boom, boom, boom. There we go. And then I will, whoops, just clean this up a little bit. Well, I think I'm going to put this into the ultrasonic cleaner now. The ultrasonic cleaner may end up turning up some more problems with a board like this with this sort of corrosion. I may find that after it gets ultrasonically cleaned, I find some other problems, and so I'll go in and sort those out before I put it all back together. For anyone who's not familiar with what an ultrasonic cleaner is or does, it's basically a bath of water with a detergent in it, and then it gets bombarded by ultrasonic sound waves and uses a process called cavitation, which helps get grit and stuff out in very sort of tight little places. The detergent that you put in is also very important as to what sort of detergent you put in. You don't just put your dish detergent in there. You put special detergents in that are designed to have maximum cleaning impact on something like this, removing things like grease and grime and dirt and flux, but without doing any damage to the metal parts, to the solder or to the components or anything like that. So that's that's basically what an ultrasonic cleaner does. It doesn't take too long to do it. It only usually takes a few minutes in there to get it clean. This one here I'll probably take a little longer because it is particularly dirty. I'll probably remove this serial number sticker before I put it in because I suspect that that serial number sticker would come off in the water. I like to try as much as possible preserve these things because it's part of the vintageness of it. So I'll get this all clean, and then I'm going to paint UV solder mask over all of these repairs and any exposed traces. And then I will be able to start putting it all back together. So we've got to obviously put all the new components on. We've got to put our little plug back on. Let's hope we can remember which way around it goes. No, I'm just joking. It actually has a little mark on it, so lets me know. And then we can sort of hopefully test it out. I do want to do another stream of doing the testing in particular because I think if everyone's invested this amount of time in watching this, I think it's a little bit mean not to show people what it's like to fire it up. I'm totally expecting that it's about a 50-50 chance that it'll work once I'm all done because, you do all the stuff that's visible, but there could be stuff there that could be corrosion that's not visible as well. Not to mention the fact that there was some indication with this board, you know, that it had been taken out and someone might have had a bit of a fiddle with it before. So, you know, as David was saying, that when he got it and he opened up, there are a whole bunch of things unplugged. So that's always a, you know, sort of a bit of a worry. But anyhow, it's you know, it's what I like about this stream is it's been good for demonstrating what these look like when they're very heavily corroded, and it should also be an indicator to anyone who has an SE30. If they haven't had it recapped, get it done. These things are not getting better with age if you haven't recapped them. I mean, just getting worse and worse and worse. So let's just have a quick look, catch up on the chat here. What do we got here? Intending to repair my Plus unsuccessfully. I replaced the ICs on the analog board. Use sockets for them. Fun slipping the new chips in them. Yep. So unsuccessfully with the Plus. It's a shame. I mean, generally Pluses, the logic boards you use are pretty solid on them. I've had problems with analog boards on Pluses, but not logic boards. I've got one. They've got one here. This is actually a perfectly working board, but it has been rated for one component, and that's right here. It's had the real-time chip taken off it, real-time clock chip. Because the real-time clock chips on these are a little bit different to other real-time clock chips, in that these are also holding the sort of PRAM, you know, the information about what your mouse speed is set to, the actual time. They're actually stored inside that chip. So it's, you can't just get another real-time clock chip from somewhere else. You've got to get one of the Mac ones. So this board was rated, that real-time clock chip is now in a Macintosh SE. But other than that, this board is in perfect working condition. And I have to say, oh, actually, there's another chip here that's been rated from it as well, whatever that is. U12D. Oh, that's a sound chip. Yeah. I'm not sure what that was taken off for. But anyhow, other than those two components that have been ripped off this board, this is in perfect working order. But yeah, I mean, they're pretty robust. I've found with these. It's not to say that they can't fail. Of course they can. You know, but I haven't generally had much problems with these, other than, you know, the wrong sort of RAM, or not configured correctly for the RAM with the little thingies here. But I'm sure you've tested all of those things there. So I do hope you managed to get that sorted out at some stage. Okay, where are we going? It will look neat, mint. It will be mint when it's clean. We'll return with a stream in 30 minutes, folks. Oh, so are you saying you're going to stream, Jay? That is awesome. If you are, give me something to do while I'm working. Totally expecting it will be 50-50, that's right. So, so many components on the analog board, and it just chirps at me. Yeah, I mean, yeah. The chirping, yeah. When they're just dead, when Mac Plus or 128K or 512K, when the analog board is just dead, they're fairly easy to sort out. I know the components that normally fail on them, but if they're giving you a bit of something, it's a nightmare. So it's great that the 128K works. It's excellent. It's a great old Mac to have in the collection. They're pretty useless with only 128K of RAM, but they're still a great thing to have in the collection. I own a 400K floppy drive. Oh, I'm resuming my stream. No. It won't be 30 minutes. It's going to take longer than that, I'm afraid. I will probably try and resume my stream maybe tomorrow. So yeah, no need to hang around for today. It won't be finished today. I've got to wash this. I've got to wash it, dry it, UV solder mask it. That whole process is going to be an hour and a half easy. Probably, making sure the UV solder mask dries totally. It could even be longer than that. So it will be tomorrow when I do the rest. So thank you everyone for joining. I do appreciate it. Thanks for sticking around. We're down to 16, so we've definitely had some drop-offs there as things I think got a little bit boring and monotonous. But thank you to everyone who's stuck around, and thank you for watching. I do appreciate it. As I said, press the like button if you haven't already, please. Or the thumbs down, I don't care. Yeah, so have a good rest of day, night, whatever. And thanks again for joining. So bye now. And are you sure you want to end your stream? Yes.